In this video we're going to cover DSL decoders. So in a device type we have decoders. There's two options, DSL and RAW. If you have a LoRa payload that is quite straightforward in its structure, a DSL decoder is very easy to write to extract the data you need. For example, if we go back to our Semtech device type we created before, this is a RAW decoder that you have a lot more flexibility with a raw decoder, but if it's a simple structure, this is an example of a DSL decoder from our manual. In here you can see we have the first call to convert the base 64 payload to a buffer, and then basically we walk through the bytes. So if you study the datasheet on your sensor, in this particular example for this Semtech sensor, we can basically ignore the first byte. That's what this does. It reads the first byte, but we don't perform any action on it. We ignore it. The second byte, we want to have that and the third byte, therefore it's size 2. So the second and third byte represent the pressure. So in this case, we do a read int, big endian, of 16 bits, which is the 2 bytes, hence it's size 2. And then to format that, we just divide the value by 10. That covers pressure. The next 2 bytes after that are defined as temperature. You can see here we do the same thing, read the 2 bytes, convert the value, this time dividing by 100, and this will give us the temperature. The next 2 bytes we can ignore. The battery level is only 1 byte. And we also have some conditional logic that the value is not valid if these conditions apply. Finally, we have the GPS. These are both 3 bytes. Now these are quite complicated in how they're interpreted. So what we've done is we call a DSL function in this case. The call statement, we can have raw JavaScript code in here, similar to the way the format is done. But if it's too complicated or it's not a one-liner, we can create a DSL function. So if we go to decode 24-bit GPS latitude, if we go into our list of DSL functions and we look for decode 24-bit latitude, we'll see that this is the content now of that function. So this function is going to be executed. The context will be the bytes that the DSL decoder is operating on. For example, it could be 2 bytes or 3 bytes in this example. So this is expecting 3 bytes, and it does a rather complex extraction to remove the latitude. And all this information will be in the data sheet on how to actually interpret this. So if we go back to our device type, and we paste in our decoder again. So that's how we're referencing now our DSL functions, and it's the same for longitude. So we can now select a payload like we did before with the raw decoder, and when we click confirm result and we click run, we get the same information back as we did with the raw decoder. It's just DSL functions are just easier ways to walk through the payload to extract the data you want.